If you're a senior cloud architect, you totally get it. The constant pressure to get data where it needs to go and to get it there right now. Well, today we're diving deep into that. We're going to talk about architecting a cross-cloud change data capture pipeline. Honestly, this is a must-have skill for anyone building systems that need to react in real time. So here's how we're going to break this all down. First, we'll talk about the core business issue, the stale data problem. Then we'll introduce change data capture as the hero of our story, and we'll look at the anatomy of a real CDC pipeline. After that, we'll walk through a practical cross-cloud example, and we'll wrap up with the really critical challenges you have to get right for this to work. All right, let's kick things off with the big why. We're talking about the stale data problem. In the world we live in now, making decisions based on data that's even a few hours old, it's not just slow, it's a huge and frankly, a totally avoidable risk. So I've got a question for you. Are your analytics telling a story about the past? I mean, when your dashboards only get updated once a day, you're essentially trying to drive a car while only looking in the rearview mirror. What's the real cost of not catching fraud for a whole day? Or telling a customer an item is in stock when it actually sold out hours ago? That delay, that latency, it has a real dollar value attached to it. This slide really just nails the massive shift that's happening. For years, everything ran on nightly batch jobs. And what did that get us? Stale data, slow reactive decisions, and super high latency. The whole game is moving towards real-time streaming. This is what gives you fresh data, immediate insights, and that low latency edge. The big question, of course, is how do you get from the left side of this slide to the right? And that brings us perfectly to change data capture. You can think of this as the engine that powers this entire move to real-time. It's the fundamental technology that lets us listen to the heartbeat of our most important systems without actually disrupting them at all. And the definition really tells the whole story. CDC is not about just blasting your production database with queries every couple of seconds. No way. It's a much more elegant, much more efficient process. It sees every single change, every insert, every update, every delete, the moment it happens, and then delivers it downstream. It's incredibly efficient, and it is incredibly fast. I absolutely love this analogy. Think of CDC as a database court reporter. It's just sitting there quietly listening to the database's internal transaction log, and it meticulously writes down every single thing that happens in the exact order it happened. What you get is this perfect, auditable stream of changes that you can then send pretty much anywhere you want. Okay, so we've got the concept down. Now, let's get practical. Let's see how you actually build this into a pipeline. We're going to follow a single change as it makes its way from inside the database all the way out to a high-speed event stream. At its core, the architecture is beautifully simple. It all starts with the database's own transaction log. That's the absolute source of truth. Then, a special piece of software called a CDC connector reads that log. And finally, that connector turns the changes into events and publishes them to an event stream. Let's dig into each of these. Here's where it all comes together. The database log, well, that's the ultimate record keeper. Nothing is officially in the database until it's written there. The CDC connector is like the clever translator in the middle, turning these raw, kind of cryptic log files into clean, structured messages. And then you have the event stream. Think something like Kafka or Kinesis, which acts as the superhighway, reliably delivering these messages to whoever needs them. Okay, theory is great, but let's make this really concrete. We're going to walk through a classic cross-cloud analytics scenario. This is a situation where CDC isn't just a nice-to-have, it's really the only sane way to solve the problem. I mean, this is a scenario that architects deal with all the time. You've got this big, old, on-premise database, maybe an Oracle or a SQL Server, that runs the whole show. And the number one rule is you can't mess with it. So the challenge is, how do you get that live operational data into your shiny new cloud analytics platform without hammering that critical database with queries and slowing it down? Well, the solution is CDC. It just reads the logs, streams the changes out to the cloud, and powers anything you can imagine. Your dashboards are now alive, showing data that's seconds, not hours old. But, and this is a big but, it is not magic. Getting this right requires some really careful architectural thinking. So let's talk about the hard part. Navigating the critical challenges. Getting this stuff right is what separates a rock-solid pipeline from one that's going to wake you up with an alert at 3 a.m. As an architect, you have to be absolutely obsessed with these three things: latency, ordering, and item potency. If you get even one of these wrong, you can silently introduce some really nasty data integrity problems that are a total nightmare to track down later. So first up is latency. We're talking about that end-to-end delay. How many milliseconds does it take from the moment a row gets updated in your source database to the moment that change shows up in your downstream system? The whole point of CDC is to shrink this number. But every single hop, the network, the connector, the broker, it all adds a little bit of time. Next up is ordering. And let me tell you, this one is absolutely critical. Imagine a customer updates their address and then places an order. You have to process those events in that exact order. If you flip them, you could ship a very expensive product to the wrong place. For a lot of systems, getting the order right isn't just a nice-to-have, it's completely non-negotiable. And finally, we have this tricky one, idempotency. Look, in any complex system, things can fail. Networks glitch, services restart, it's just a fact of life. And that means sometimes you might get the same event delivered more than once. Your downstream systems have to be built to handle that. An idempotent system is one where processing the same event 5 times has the exact same result as processing it just once. It's a critical safety net.
So this table really brings it all home. These are the big architectural questions you have to answer. For latency, you got to ask the business, how real-time is real-time? Is a few seconds okay, or do we need sub-second? For ordering, what's the actual business impact if we process things out of order? And for e-dependency, what's our plan for dealing with duplicate messages? These aren't just technical details, they are foundational decisions for your design. So we've gone from the problem of stale data to the solution with CDC, through the architecture, and right into the weeds of the critical challenges. It's an incredibly powerful way to modernize how data flows. So I'll just leave you with this final thought. Now that you see the amazing potential and the tricky pitfalls, where in your world could your first real-time pipeline make the biggest possible impact?